Cataloging the Flora of Viharamahadevi Park. A novel artificial intelligence-driven approach by Nuwan I. Senaratna. Viharamahadevi Park is a public park located in Cinnamon Gardens, Colombo, situated in front of the colonial-era town hall in Sri Lanka. It was built by the British colonial administration and is the oldest and largest park of Colombo. The park was originally named Victoria Park, after Queen Victoria, but was renamed after Queen Viharamahadevi on July 18, 1958. Viharamahadevi Park is 24.27 hectares and has an estimated green cover of 14.39 hectares, or 59% from the total area. The estimated crown cover is 12.25 hectares, or 50% of the total area. Viharamahadevi Park has a rich collection of flora, which several researchers have attempted to catalogue. In this video, we present a novel approach to plant cataloguing, which combines computer vision, artificial intelligence, and smartphones. First, we take a photograph of a plant. Using a smartphone, the photos could be leaves, flowers, the bark, or the entire plant or tree. Exchangeable Image File Format or EXIF is a standard that specifies formats for images used by modern digital cameras, including smartphones. As part of EXIF, photos are tagged with various types of metadata, including geolocation, that is latitude and longitude, camera angle, direction, and focal length. Using this information, we can accurately determine the location of the plant or tree. Next, we must identify the plant. For this we use PlantNet, a citizen science project for automatic plant identification through photographs. It is based on machine learning and computer vision. Launched in 2009, PlantNet has been developed by computer scientists and botanists from a broad consortium of French research institutes and their global partners. PlantNet also provides a comprehensive application programming interface, or API, that enables efficient programmatic plant identification. The API can be used free of charge. When provided with a photo of a plant, PlantNet returns a set of predictions on probable species, along with a confidence score. For example, PlantNet is 91% confident that this photo is of Mesoeferia. We applied this process to 1,601 photos of plants from Viharamahadevi Park. Of the 1,601 photos, 1,576 were within the official boundaries of the park. The remaining photos were of plants or trees on the surrounding roads. There were some duplicate photos of the same plant, which we removed. This left us with 1,554 photos, each representing a unique plant. Of these, for 1,398 PlantNet identified the species with at least 5% confidence, 1,189 with at least 10%, 935 with at least 20%, and 521 with at least 50%. Based on a random inspection, identifications with at least 20% confidence proved to be correct. Hence, we considered the 935 to be our catalog dataset. The most common species of plant at Viharamahadevi Park was, appropriately, Sri Lanka's national tree, Ceylon ironwood, or Mesoeferia, which accounted for 7.1% of all catalogued plants. Next came Terminalia arjuna, 5.3%, Mangifera indica, 4.1%, Terminalia catappa, 3.1%, and Pongamia pinnata, 2.9%, followed by Artocarpus heterophyllus, Cassia fistula, Tectona grandis, Peltiforum pterocarpum, and Tacoma stans. This top 10 is consistent with surveys done in the past. We generated various data visualizations of the catalog dataset, including this sunburst diagram that visualizes all the plants at Viharamahadevi Park weighted by frequency. We also developed an map-based app for pinpointing each plant. In this screenshot, we've selected one instance of Ficus religiosa, the famous boar tree. In green are other instances of Ficus religiosa. In orange are plants of the same genus, Ficus, including Ficus bengalensis and Ficus virens. And in red are plants of the same family, Moraceae. The app can be accessed at known.github.io/plants. Our approach can be easily applied to other parks, and even much larger collections of plants, like botanic gardens. It is simple, cheap and efficient. The only drawback we've identified thus far is that prediction accuracy is poor for a few species of plants. However, this problem is likely to be solved with more training data and improvements to the AI model. Thanks for listening. For more details, please contact the author, Nuwan I. Senaratne, at me@nuwan.org.